Hello, sorry about that. Small problem with the storage, which we had last time, so I've got somebody helping me film this time, so the video goes a bit weird, that's why. I was just going to carry on from where we left off. So last time we mentioned how along our chromosomes we have these nitrogenous base pairs which code for specific amino acids, which code for proteins in turn, which make up our genes. Okay, so there's also another very important part of the DNA molecule which we need to go through, which will come up in your exam. Some parts of the DNA molecule along this chromosome do not code for amino acids or proteins. So the ones we've talked about so far do, but there's also parts that are very important that do not code for amino acids or proteins. So they're not coding parts of the DNA. They're called non-coding DNA, so that's easy to remember, non-coding DNA. They have another name as well, short tandem repeats, if you can remember that, short tandem repeats, or STRs. And these are linked to DNA profiling or fingerprinting and used in solving crimes, so forensics. So you've seen how the pattern along the chromosome, base pairs are lined up in triplets and the code for amino acids. Amongst this chain, throughout, there are thousands and thousands of non-coding areas of DNA. So it's still DNA, but it's not coding for anything. They're scattered throughout the chromosomes, and every so often these sections are repeated. So the same sections repeated over and over again. They're not on this diagram, but I'll try to get another. And that's why they're called short tandem repeats. So they're short sections, and they're repeated over and over again. And the number of times they're repeated is what builds up our genetic profile. If you have enough DNA, then you can make an entire genetic fingerprint. And scientists have actually came up with a way to make these visible, so that patterns can be compared from different samples. If you're working in solving crime, then you can compare the samples by looking at the diagrams. So I'll show you one of these diagrams now. So go this way. So here we are. These are the short tandem repeats, so the areas which are non-coding DNA, but they repeat every so often and are used in solving crime. So they're used to build a genetic fingerprint. So when you see them, they show up as bands like this, patterns of bands. So if we look at an original sample, which might come from a crime scene, they might take this from a victim of crime, and they've mapped the short tandem repeats. So it's come up as a big thick band here, then a thin one. Here we've got two thin bands, then one thin band, a thick one and a thin one, and two thin ones again. So you can see how they repeat every so often. So it's this victim which we're comparing to the samples which we've taken from the crime scene. This can be anything from hair that's found, or saliva that can be taken from a suspect, or even cells which can be taken from somebody's clothing. So if we look at sample number 1, you can see we're comparing it to the victim here, to the sample we've taken and mapped. And you can see we've got a thin band which lines up with this one, but there's no thick band. Here we've got two thick bands instead of thin ones. Here we've not got a thick band. So we can already see that this sample from hair is not corresponding to our original sample. If we look at sample number 2, at the top we've got a thin band which doesn't appear, but then we do have a thick band and a thin one, like this. But then we've got another thin band. We have one thin band here, matching this one, but we're missing another one. And again we've got the thick band and the 2 instead of just the one thin one. So sample number 2 from the saliva doesn't really match up with number 1 either. If we look at sample number 3 now, it's not got everything there, but we do have one line at the top, which if you come across lines up with this thin line at the top of our original sample. And then we've got two thin lines. We've got two thin lines here. We've got one thin line. We've got one thin line here. And then we go back to having our big thick line and a thin one, which matches our original